Morning, everybody. Welcome to the webinar. This is a webinar which is one of a series of webinars covering process safety management from the context of mechanical engineers. Subject matter for today is around how we know whether the barriers that we think are in place are in fact working. So in terms of today's agenda, we have relatively less presentation today and a bit more discussion, and I hope this will provide some interest. First case study we're going to talk about is the Buncefield explosion from 2005. Now, many people will be quite familiar with that, so I'm not going to go into a huge amount of detail, but I do want to draw out some key points. We'll follow that with a panel discussion. How will management know how things are going? And I'm hoping, therefore, through that panel discussion, to give you some perspectives on assurance processes from design, equipment suppliers, construction and operations. So across an equipment life cycle and over a number of different sectors as well. We've got opportunity for further questions at the end, and as questions come in, I'll try to marshal those and put those to the panel as well. So before I set off on Buncefield, quick introduction to me. My name is Richard Roth. I'm Group Process Safety Director for Costain. Bit of background, I've spent about 20 years in the chemical industry and 5 or so years in steel making before I joined Costain. It's getting on for 9 years ago now, but bringing the ideas of process safety management to different sectors over my career. So talking about Buncefield, just a bit of background to what Buncefield is. As I say, I guess people may be familiar with it, but just to be clear, Buncefield is a large tank farm site near Hemel Hempstead in the UK, built in the late 60s. In essence, there were a lot of above ground storage tanks with controls and bunding, as you might expect for such a facility. In fact, it was being the site had 3 different operating organisations. So the Buncefield depot had a number of different operating organisations within it. There were 3 feeding pipelines coming into the depot, and the way materials were fed, and those materials are fuels in general, was by batch transfers. The materials went to material dedicated storage tanks, so in essence product dedicated storage tanks. Outgoing flows were largely through road tanker, but there were two outgoing pipelines as well from this depot. Approximate quantities, adding up the various licenses at the time, was about 150,000 tonnes of motor fuel and around 40,000 tonnes of other fuels, so aviation fuel essentially. The pipelines coming in were essentially from across the UK, so refineries in different parts of the UK, so they're long distance transport pipelines. The outgoing pipelines were essentially, although to other parts in the southeast of England, also to airports, major airports in the southeast of England. So that's the site and its operations. The incident occurred on the 11th of December 2005. A pipeline delivery to tank 912 of gasoline, petrol, had started on the 10th of December. Around 5:30 in the morning, the overfill protection on tank 912 failed to stop the flow, and the tank overfilled. That created a vapor cloud. Well, firstly a liquid spill, and then above it a vapor cloud. And that vapor cloud actually spread beyond the site boundaries, so not just outside of the bund in the site, but beyond the site boundaries. Vapor cloud ignited just after 6 a.m. and there was a major explosion followed by a fire. And the images you can see, the tanks involved in the initial failure in the top view but also the weather conditions in the UK at the time were quite still and cold. There was something of an inversion, and the smoke plume was visible from some distance away. You can see in the bottom photograph. Result of that explosion and fire is that the depot was severely damaged, but also a number of neighbouring buildings were severely damaged, and I'll show you some photographs of that in a second. Fires took 5 days to put out, ultimately, including waiting for some fires to burn out, because that was the safest thing to do. Now, in terms of the effects, no one was killed in this incident, but 43 people were injured. There was environmental damage as a result of the spilled fuel materials and also the firefighting. And I've seen estimates of 70 million cost to local businesses. And the sort of most significant longer-term effect with regard to lack of fuel, a lack of ability to spread fuel around the country, was probably at Heathrow, and so that's the largest airport in the UK for any non-UK listeners. You can see from these photographs that the damage was clearly extensive within the site boundaries, but you can also see that the neighbouring facilities, which is a light industrial estate, sort of in the top left of the photograph, which is underneath the words there, but you can see images from that industrial estate over on the right. In thinking about the explosion and its immediate aftermath, it's worth noting that the fuel in question, as I said, was gasoline, and gasoline's components change throughout the year. So during the cold months, there are more lighter fractions in gasoline. So there may have been as much as 10% of butane in this case. And ultimately, there were some queries around the time about how our global understanding of how an explosive mixture could occur above vaporizing gasoline, and indeed how a vapor cloud explosion in such a vapor cloud could accelerate to detonation speeds to cause the kind of damage you see in these photographs. That there was a need after this event to do some research on why the overpressure from the speed of explosion, the vapor flame front in the explosion had caused such damage. That said, we need to think about, rather than unpacking the details of the incident itself, I wanted to move to recommendations. So there was a major incident investigation board put together. So in essence, an independent investigation as a result of this event. And the MIIB made a number of recommendations, but they made recommendations in these areas. So systematic assessment of safety integrity levels was a focus on equipment and understanding its reliability. Prevention of loss of primary containment seems obvious if you're in the business of storing hazardous materials, but how do we actually prevent the top event from occurring? Engineering against escalation, so that is, can we spot a loss of primary containment and prevent it escalating any further? And then there was engineering against loss of secondary and tertiary containment. So whilst I have not shown any photographs of this, there were a number of issues around bunding and then tertiary containment, which meant that there were environmental damages beyond what might have been expected in this case. Other areas of recommendation were the ideas of highly reliable organizations and a number of aspects to how organizations become highly reliable in managing major hazards, and culture and leadership. So this is the idea that perhaps for organizations to become highly reliable, they do need impetus and interest from the very top of those organizations. So I think about that in terms of what you might call a safety or environmental management system, then you get these kinds of areas to think about. So this image is one that we use in my organisation, but it is based on the sorts of Plan, Do, Check, Act requirements that we see in ISO 14001 and 45001, and indeed many other ISO standards regarding non-safety fields. So, okay, leadership is interested, requires planning. Once we've planned what to do, we need to get on and do it, and there may be an element of support to operations as well as operations themselves. At some point, we've got to think about performance evaluation, and if we're happy with that, great, more of the same, please. If we're not happy with that, we may wish to change, and it may be that we wish to change for other reasons as well. So this becomes a cycle, and all of those recommendation areas really show in this kind of cycle. So planning, design, do we understand safety integrity levels? Then when we get to support and operations, are they in place? And so on. And likewise, we would see the same sorts of circles around each of those MIIB recommendation areas. So in thinking about the theme of today's discussion, which is assurance, we could ask ourselves, well, where might we seek assurance in terms of these 6 areas? And it's my view that it's possible to go and look under stones and look for creepy crawlies and look for compliance and look for the right things going on in all of these areas that I've highlighted. And when we understand whether leadership is doing as it should, whether planning is going as it should, and so forth, then we've got the opportunity to evaluate performance. We need to ask, are things going as we would want them to go in all of those areas? I've added improvement in there because, let's say we choose to make an improvement, we would want to make sure, A, that it was installed properly, and B, that it had the effect we thought it was going to have. So sometimes that can be forgotten, whether it be responses to incidents or improvements made with intent. Actually, did it work is a question that we all always ought to ask. So if we think about assurance, what I'm interested in here are audits, assessments, inspections, reviews, records of those. Sometimes one has to take care with the language of assurance. If I were to go and do an audit and seek for assurance, I might actually, by the very nature of that word, be heading towards confirmation bias. So take care, but we need to understand as operators in industries with high hazards and managers and potentially leaders in those industries, are things going as I thought they were going to go? So this photograph is a snip taken from a news bulletin. We use this in some of the training that I deliver and that we deliver in my organisation. But these 3 people are Gordon McDonald in the centre from HSE, and Colin Chiverton and Bob Woodward. So Colin Chiverton from the Environment Agency, Bob Woodward was the lead investigator. Now, in this clip, Gordon McDonald is saying, from the boardroom down, companies must ask themselves, do we understand what could go wrong? Do we know what our systems are to prevent this happening? And do we have information to assure us that they are working effectively? So it's really that third question. What can go wrong? What's got to go right? And how do I know that that's happening? So just by this little clue, I'll let my colleagues know that I'm ready to ask them a few questions. But that said, what we want to do here is to have a discussion. So I'm joined on the panel today by Martin, by Pamela, by Stephen, and by Murat. So just a brief introduction to each of these folk. Martin's involved in the brewing industry, has been involved in food and drink industries, but also briefly in other sectors as well in terms of petrochemicals, and he's been involved in those industries across the world as well. Pamela is currently working in the water sector, but has also had some experience in the petrochemical industry. So Pamela works for Atkins and is involved in, I guess at this stage, I'm thinking about the design phase of capital delivery. Stephen is system engineer at Sellafield, and although he may have less experience than the rest of us, the insight into how the nuclear sector does things and how systems engineering and system engineering works will be useful. Murat's mechanical engineer works for John Crane. So John Crane are involved in making coupling and sealing equipment, some of you might well be familiar with, so I'm interested in ideas from equipment manufacturers and where and how they see the world of assurance in terms of process safety. So I guess I'll try and randomly start amongst this group. Pamela, if I could come to you first, can you tell us first what industry you're currently working in, what equipment lifecycle stage has taken up most of your time, and then a little bit about what has to go right from a process safety perspective in that case.
Thank you, Richard. Yes, I'm Pamela Robinson. I work for Atkins in the water and wastewater industry. In my current role, I'm actually seconded into Yorkshire Water within their engineering design team, which is a newly formed team. We look at the schemes coming through from the capital delivery aspect, so the new schemes coming through on water and wastewater. And as part of that, as the schemes progress from optioneering through to outline, through to detail, and then onto construction and commissioning, there are several gates within the Yorkshire Water process. And myself is part of a team which assures the projects as they come through to check that they are technically compliant and compliant from a process safety point of view as well. Make sure we're doing all the design team are doing the right aspects at the right stages and is delivering a design that is Yorkshire Water compliant. To make sure that the things must go right, we make sure that the contract partners follow the IMechE 7 stages in the capital delivery world. So we, in the optioneering stage, we do the hazard study 1, the overall to look at the overall scheme, where it's going. Are there any external hazards that could affect the scheme and affect the options that you'd put forward? Hazard study 2 is then high level initial hazard identification of the scheme coming through, generally done after we've got a single option on the table. Then hazard study 7, is completed at the same time if there's any decommissioning aspects of that. Then your hazard study 3 is done when you've got a detailed design on the table and that you can review. You've got more information, and that is a more systematic done through your P&IDs, using the P&IDs as nodes and keywords. Then your hazard study 4 is done to confirm that you have built what you intended, and it's prior to commissioning. So before you turn anything on, just make sure you've got all the systems in place, that everything works as it should before you get any live fluid through your system, new scheme that you've built. Hazard study 5 is then to check prior to handover, or check before you turn the actual chemical, put the actual chemical flow through the system and check it's suitable for handover. And hazard study 6 should be done 6 months after it's been operated, to just double check it is operating as it's intended, has there been any tweaks, that then needs to be fed back as a lessons learned and affect future designs going forward. At all of those key hazard studies, we make sure that we have the correct representation there. So we have members from the design team, we have members from operations, we sometimes have ourselves from engineering design. We could have people from process safety as well involved, make sure we have maintenance there, because there's no point doing something in silo. You have to involve the relevant parties that are going to operate and maintain that kit, and who perhaps know the site in more detail than the design partners. And at all those relevant stages as well, we make sure that we follow all the relevant legislation, such as DSIR, hazard study, LOLA, for example, depend on what is already at the scheme, already there on site, and what the scheme consists of. Thank you.
Excellent. Thank you. Yeah, that's really useful nutshell explanation of the stages of hazard study, but you made the really valid point that a study is kind of worthless if the right people with the right representation aren't there. So that's really useful. Thank you very much. Can I come to Murat now? Murat, you work in equipment manufacturers and suppliers in John Crane. How do you see the sort of world of what must go right? Just tell us a little bit about where you work and what on first.
Sure. Thank you, Richard. Yes, I am working in the rotating machinery industry, obviously, so it's quite a dynamic environment to operate in. I'm sort of mainly doing design engineering, research, product development functions, and involved in those stages for the power transmission couplings for quite heavy machinery, actually. So we obviously need to make sure the products are sufficiently designed for standards, industry standards, so we ensure adequate safety factors for fatigue conditions, fatigue cycles, high cycle and low cycle. So we need to understand the materials and manage all the tolerances within the product, geometrically as well as from a material point of view. And understand when you put all these different components together, how they interact with each other, and ensure that they actually function as we expect them to be functioning. So you may find people are looking at components individually, but when you put them together, they behave completely differently, especially if you put them in a dynamic environment. So we sort of try to manage all these different stakeholders, their needs, understand what actual safety factors required for different standards, because they're all down to interpretation. We have to agree on what we should be working towards. Because we have a lot of rotating machinery equipment, we have bolted joints, understand those adequately. All the corrosion, friction, wear, all those different aspects need to be investigated and controlled somehow. And most of these things may be statistics driven rather than actual test driven. So sometimes we have to do physical tests to ensure the compliance as well, to gain confidence in the product and prove the confidence in the product as well to our customers. I think in a nutshell, this is sort of is what I should really talk about. Is that okay?
Absolutely, thank you. Yeah. So the key points there are that I picked up from that are around not just looking at items in isolation, but looking at items or components together. Starts to get us into the world of the system as opposed to an individual component. And it's obvious that in where you're sitting, the quality aspects of have we actually provided the equipment? Does it physically meet the specification, as well as have we assured that it meets the specification, become relevant? I guess things like fatigue and sort of client requirements. Do you have to have some recirculation with the client with respect to what are the conditions going to be? I presume there's a need to sort of button down the eventual conditions for design. Otherwise, it's a bit difficult to say where to stop. Yeah.
that is always a difficult discussion to have because customers will come to us with some RFQs, requests for quotations. They will put some values into the document and they want us to design to a specific standard. And we have to obviously select adequate safety factors for the design. But what we don't realize sometimes is the customer themselves actually put safety factors into their requirements without telling us. So we end up over designing products, or they're forcing us to select larger products sometimes. So
okay, that's interesting.
If we don't understand the requirement clearly, where this product will operate and what the actual duty conditions for it will be, what will be the peak conditions, we obviously have to be cautious and select the worst case scenario safety factors for it. And there are a lot of money to be saved actually if we understand what the real requirements are for the test environment, let's say.
Oh, indeed, and for me that is what engineering is. We do use codes for very good reason, but at the same time, brain power, if you like, is where engineering came from. Anyway, that's the subject of a different webinar on a different day, I'm sure. Yeah. Okay, so thanks, Murat. I'm going to come to Stephen next. Firstly, tell us what you do at Sellafield, but then I'm going to ask you a slightly different question, Stephen.
Yeah, thanks, Richard. So my current role at Sellafield, as system engineer, I'm responsible for the plant health, if you like, of an intermediate level waste store. So this store dates from the late 1980s when it was commissioned. Intermediate level waste being the sort of stainless steel drums full of cement, and in that cement you've got various different stainless steel components from sort of Magnox fleet reactors, AGR casings, and so on as well. So my role is sort of mostly in the sort of dry process, the mechanical handling of these waste items. Obviously, being intermediate level, it's not the really nasty nuclear stuff that you hear about, but you wouldn't want to find yourself standing next to a drum.
Right. Yeah.
So it's very much an operational plant that's in the context of Sellafield quite young, but it's still sort of 35 years old and is going through life extensions. There are lots of modifications being done to help bring in some new waste streams to reduce hazard across the decommissioning part of the business.
Okay, thank you. So in terms of maintaining equipment and maintenance, there are generally regimes for testing, routine inspection or inspection on some routine basis, and so on. How are you kind of finding out about that? If you're managing that, how do you know that's happening on time, in full, and indeed if it's finding something, what it's finding?
Yeah. So the main sort of critical components in the system are defined as safety mechanisms by Sellafield. I'm not sure if that sort of term goes across the wider process industry.
That's your local term, and yeah, I mean that's probably pretty generic. It's not necessarily a term I've used in the past, but yeah, go for it.
Yeah. So as part of the safety mech status, anytime that sort of piece of equipment is maintained or has to be defeated for testing or anything, it goes through a proof test. So that can be proving that if it's said to prevent a personnel access to a cell when there's active material in that cell, it's proving that you can't open a door or that certain lights aren't lit. So if you've got, say, twist locks on a hoist to lift a flask, if those twist locks are engaged, you can't then get access. You've got multiple levels of alarms in these areas, so gamma radiation, beta in-air contamination alarms. So there's multiple levels of that, and it's all recorded into a wider trending and learning system. So any sort of revealed failures are then fed across the wider site to sort of share that learning, because I mean Sellafield has 10,000 plus people on the site, and culture is really a huge thing across the wider nuclear industry. So sharing that learning and keeping it at the forefront of everybody's mind about how things can go wrong and new ways that we've not seen is really, really important.
Okay, so this is, I mean, some of the weak signals that one might see from maintenance that are relevant to process safety is whether or not we're actually getting maintenance done. Now, when we talk about safety mechanisms, they would be of a higher priority than general maintenance, but what I guess one can infer from general maintenance is what's next at risk if one thinks about it. Okay, so you talked about modifications, making sure that the modification is the right modification is usually the subject in many industries of quite a lot of brain power being applied. Is that true also at Sellafield in the nuclear context?
Absolutely, yeah. Sellafield has its own process. It's got a lot of processes, but this one's the plant modification proposal. And it's sort of one of the central areas of my role. So the sort of seed that brought this process out was actually Chernobyl, because what happened there in the 1980s was the result of an experiment. So any sort of experimental work or modification, especially to those safety mechanisms, has to go through this process, and that involves drafting a proposal that goes through essentially everything you would need to look at, down to emissions, dose levels for people, stuff like that, and that will go to committee. Then it'll be categorized in terms of how much intensity it needs. So you'll have an independent safety person, the person who's sort of head of operations of that plant, engineering managers, and radiation protection authorities, your RPA, will be in attendance of that as well as conventional safety. So that's the sort of management process, and then you can look at whether it's a permanent or a temporary change, and that sets a limit as to when you need to have that sort of bottomed out, closed out. So if you need to change drawings, that they're up to date. If you need to change the safety case for the plant or any part of that's all done, and it's really an assurance that everything is sort of finished, signed off, and complete.
So that's certainly a barrier. Okay, thank you for that. I'm going to come to Martin now. Just thinking about the sort of operations you've seen, I guess, Martin, just firstly explain what you do in the industry you work in now, but thinking in the sort of food and drink context, what sort of things have to go right when one is working in those contexts? Well, just maybe Martin's. Are you muted?
No, I'm not.
So there you go.
Okay, yeah, I work in the food and drink industry, mainly as a designer, troubleshooter, and client's representative. So basically, it's normally front end stuff. But I have worked in maintenance in petrochem in a former life, for example. My aim is not only to get the design right, but also to train operators and maintenance staff, which basically means sending them off to the maker's men to get them trained up properly and things like this. Now, I feel that one or two items at Bunsfield may have come out differently if the maintenance people had actually been to a workshop at the makers. I'm thinking
absolutely, yeah.
I'm thinking particularly of the level device, the high level cutout, which was
indeed so, yeah.
designed to do two functions. It was supposed to control at high level and low level, and was set up incorrectly. If the designer and the project team had actually purchased a level device that only worked one way, only worked at high level, or the operators have been told, gone through a procedure and say this is the consequences if you put it in wrong, that maybe the tank would not have overfilled. So, I talk about examples. I have an example in a brewery, which basically is to do with hot water, and everyone thinks, oh, that's pretty tame, hot water. But what happened was they had a problem with the process and the heat exchanger, countercurrent heat exchanger, which was used to cool beer or worked in beer by running cold water through it to produce hot water for the next brew. It's quite a common process in the food and drink industry. What happened was they had a problem with the heat exchanger, and the tank overfilled. The hot water tank overfilled with water about 80, 85 degrees. This was spotted by an Environment Agency spotter plane, seeing the water running into the Thames via a tidal valve on the banks of the Thames.
Wow.
Now that's 80 degrees. So we killed a lot of fish that day, got a big fine, simply because no one thought this tank would overflow. And when it did, it was not connected to the effluent treatment plant. It was not in a bunded area. It just flowed directly to the surface water drain. Which,
okay, so in this instance, that's an interesting example. Actually spotted not really through assurance, but through an incident. But if design thinking had included it in this has to flow to effluent, and actually we don't want it to overflow, that would be helpful. But you made a really valid point earlier on around training. So training and understanding of equipment, how it works, why it works, is a sort of vital feature and shows up in incidents all over the world. And that's a really good point. Okay, just thinking about sort of the way information surfaces and with whom. Can I come back to you, Pamela? You talked about managing stage gates and making sure representation is right. Are you aware of a process by which that kind of information is all kind of grouped up into a dashboard and shown to some sort of project board in some form?
Yeah, it's always tried to represent pictorially to try and make it easier to see who should be at which stage, what should be presented, who should be present, what is expected of the meetings. We have it as meetings, so what's expected at the meeting. We run through a typical presentation where everything is presented to the review team. Documents are uploaded in advance so we can assess the documents beforehand, come armed with relevant questions, and then at the end of it go away with comments. So that's, and we try to do that as pictorially, as visually as possible, because we understand that lots of words, it does get lost, but it's a continual process. We're not saying it's perfect first time at all. We are continually trying to make it better. And if there are errors, if people miss going through the gates, we investigate how have they missed it? What have we not communicated correctly? So we don't ever think we're perfect. We always
indeed, I mean, that's an interesting area about what do organisations perceive to count as an incident, and it's an area that I kind of moving further to left in the project program as I have in my career. I've been sort of challenging my colleagues to say, well, if we find that not everybody has shown up to this meeting, we could just say, well, it didn't take place, we'll have to do it again, and that I suppose is a sort of fail-safe approach. If we try to move ahead at risk, let's say, do we perceive that to be the same as an incident where somebody gets hurt, or a potential incident where somebody could have got hurt? And I mean, it's a question without an answer, but it's a challenge to industry. Is what should we be thinking about investigating? And whilst we're talking less about investigation on this occasion and more about assurance, you made a good point about representing data pictorially. So the idea of sort of dashboards with multiple indicators on comes up. Okay, just flashing screen about something, not sure what that was. So yeah, I think it's kind of important. Do you think that information should be different at the at the sort of functional specialist level than it is at a global leadership level? I'll come back to you, Pamela.
Should that information be different?
Yeah, the sort of information that's in a dashboard for let's say the capital delivery group ought perhaps to be different from the dashboard that the CEO sees. Now, some of it ought to be common, but the CEO has operations as well to worry about, I guess.
Yeah. No, I think they need to see the high level, see where things are going adrift, to maybe where we need to tackle, where we need to bring it back in line. But the detail, I don't think they necessarily want to see the detail.
So when I looked at the recommendations about highly reliable organisations, it's kind of important then that the leaders in an organisation are listening to their specialists. So one of the traits of highly reliable organisations is you listen to your specialists. If they're saying it's off message here in maintenance, let's say, or we seem to be over designing things in equipment, then that's interesting. Okay, so I've got a couple of questions coming in. I'll try and get to all of them and maybe group some of them up. Got a comment from somebody who works in the rail industry who's refers to the common safety method, which is quite heavily related to and based on the 6+ stage hazard study that Pamela referred to. So, I guess other industries, certainly that I'm familiar with, use the structured process, but it isn't necessarily regulated or required by regulation in quite the same way. If I come to you, Stephen, are there any sort of nuclear regulation requirements to do some of the things you were talking about, or are they internal Sellafield type requirements?
Yeah, so we have our internal Sellafield requirements that drive a lot of the processes that we have, but they're in turn driven from the ONR, the Office for Nuclear Regulation, and we're also steered by the Nuclear Decommissioning Authority as well from the government. So we do have our own processes at Sellafield, but they're generally sort of from on high.
Okay, right. And so an interesting point there, and certainly I have noticed this with respect to rail and to some extent in other sectors. If the studies that Pamela referred to are seen as deliverables, there's a chance that people are just delivering them and not necessarily using them as the tools that they were intended to be. So, if a study was supposed to throw up problems with operation and maintenance, at the hazard study 3 level, for example, then did we do the study becomes potentially more important than did we find anything. And for me, there's then a quality issue that would be difficult to spot with a sort of audit program, but might be possible to spot if the people in the meeting were thinking, hey, this isn't quite delivering what I had in mind. Okay, there's a couple of other questions. Right, so there's a question that perhaps relates to Martin's comment about training. What's the panel's experience of the level of training provided to individuals in industries where those individuals are key? The question says to the process, but let me expand that to key to process safety. So, Martin, what's your experience in terms of training in the food and drink area?
I think this really depends very much on the size of the business.
Okay.
The bigger boys, the Molson Coors, the Guinnesses, and companies like this will spend an awful lot of money on training people, and they have a culture of safety within that company. So training becomes a high level. The big problem is in your microbreweries and your smaller regional breweries, for example, where safety seems to be much less important than actually getting the beer out the gate. So I think there's a definite difference in the industry, and the consequences are accidents happen, and this is a real problem. So I think, to be honest, training for safety is a bigger an issue is training to maintain the equipment.
Okay, and in my view, sometimes maintaining the equipment equals safety or process safety. So
Yes.
if I come to Murat, I guess part of selling rotating equipment is potentially an offer of training how to maintain and use it. Do you see, or have you come across differences in the way clients or customers perceive that training?
Yes, we do deliver a lot of training, actually, external training as well as internal training. So how to install a coupling into their system, how to maintain it. But really, our couplings are so designed that we actually don't need to maintain them. So that side of it is actually limited in a way. We don't want them to maintain it.
Okay.
But regarding installation and operation and the limitations of certain things, like they must not take certain things apart. And if they do, we can't guarantee any safety. But sometimes customers do this. So we have to advise them and train them on how to treat the product and how to respect it, basically, as well.
Okay, that's. I mean, I can see why an inherently safer approach is to have no user serviceable parts. That makes eminent sense to me. I guess part of when we're talking about, I don't know, a coupling from a gas turbine, then people can see the whole thing is quite special. Some of the concerns that I've seen over the years are relatively mundane things that need routine maintenance, and actually potentially at an intervention there's an opportunity for an error, and Martin alluded to the mistake made in Buncefield, in the case of the Bunsfield incident, where the equipment had been maintained and put back in a place that meant it couldn't work, or in a way that it couldn't work. So yeah, okay, so I'm also seeing cash comes into it. Well, okay, so here's some product, whether it be a minor item or a whole facility. You want the training. Yeah, we'll have the minimum amount of training, perhaps because that reduces the apparent capex. Or when the training comes around, we have or haven't got people available to be trained, and ultimately, I guess suppliers have to limit their liability by writing a contract that limits how much training goes on. Okay, that's interesting. Thank you.
Can I just mention something?
Yeah, go for it.
Training of trainers is also very key in my industry. Basically, you have people that refresh their teams, refresh the knowledge of their teams, and you have a group of people that their job is to train other people. So training those trainers is very, very critical, and they should be, top-notch people in a really good position.
So what's important for those folk is not only that they know technically how to do it, but they can also pass that information on. So again, one could imagine auditing that process, as in, let's go sit at the back and see whether these people can really get their message across. Certainly, I deliver training within my organisation, and some of it is accredited by external bodies. And those external bodies come and they sit at the back of some of my sessions and they give me feedback. But ultimately what they're checking is, can I get my message across? Which in some respects might be more critical for a trainer than absolute knowledge of, which screw attaches to which nut. Yeah. Okay, thanks, Martin. Okay, a couple of other questions. I'll come back to the technical ones in a moment. One is around the extent to which maintenance and testing of devices is really considered at the asset design stage. Can we actually test this? Let's say we've defined its safety integrity level, but could we test it? Certainly, I guess where this is coming from are the issues of, once it's installed, it can't ever be tested end to end, perhaps, and I've certainly seen that issue myself. So perhaps, Pamela, do you think that gets enough attention during the design phases in the water sector?
It's certainly something that will be questioned within the hazard studies if they're being done correctly, as mentioned earlier.
Yeah.
and not just a tick box exercise. Or we have complacency if people think, oh, it's just another pumping station, or it's just another one of those. You get complacency and get errors that way. But it's certainly a testing the way you can test that is when it's sorry, I'm struggling with my words. But when it's in operation, yes, we should have the facility to be able to test it, and it will be questioned within the hazard study 3. I would have thought it would come up there to see.
Sure, no, but the point you made, the point you made about representation is if there isn't somebody who understands how testing really works in the field, then we may miss out on that insight on, hey, it can't be tested, or if you chose another way, we could test it.
Yes, exactly. So there could be complacency if you don't have the right person. You can say, oh well, they could think, oh well, we've got one of those at Site X, so it must be okay. Whereas if you have the person from Site X, then they would know what's been done to that to make it suitable. There may have been site mods. Hence why if you do follow the full hazard study process at 6, when you've got your handover and you've been operating it for 6 months or more, and you've had to do modifications, you then feed that back in. So
hopefully that goes back to the design and not to do it again. Yeah, absolutely.
Yes, you don't keep making the same error.
Yeah, and what I find difficult about that, working now in the construction sector, is the designer may well have been finished on their contract long before that knowledge is kind of developed, particularly if it's 6 months or more down the line. So it's kind of incumbent on owners of the asset to manage that knowledge, is it not?
Definitely. In Yorkshire Water, the Hazard Study 6 is done by the client, but then, it should be then fed back into the new design team, so the new contract partners coming through and the lessons learned. But definitely managed by the client. It's their duty really to do it.
Yeah, and it is an area of tension, isn't it? Because the design group may or may not be the same group as last time, and so on and so on. Okay, there's perhaps an interesting question coming up about, do we have too much paperwork and not enough understanding? I won't ask you all to answer that question, but I think some level of record is important, but recognizing that the documentation doesn't make it safe, it's the people and what they do that make it safe is a quite important part. There is a question about linking assurance to process safety performance indicators. I'll give you my impression first. I think, is assurance happening, and what it's telling us are pretty key, quite global level performance indicators. Now, if we had a record of a particular inspection, then we may get some details, but at the sort of leadership level, have I resourced audit? Are they getting done on time? Is there an audit team? Is there a home team? Are we allowing this enough time? Is quite a good indicator of weak signal indicator of potential problems. So certainly in our organisation, we are monitoring: are the audits getting done on time? How many times out of 100, let's say, do we find any issue? How many times out of 100 do we find issues that are more than minor? And indeed, we also monitor how many times out of 100 there's good stuff to share. So now, okay, that doesn't mean we're sharing it, but at least it gives our leaders the opportunity to go, okay, we're still taking this seriously. Now, if we weren't delivering on time in full on our audit program, I would be advising my leader colleagues and expecting my leader colleagues to be saying, no, this is important to me. I need you to step this up. And that's duly what we have been able to see. But this becomes then, whilst it's not that directly attached leading indicator, it's definitely a leading indicator to process safety. Now, what you do have to do is be sure that you're auditing the right things. Because if I go out and I'm just checking whether people are wearing their glasses on site, that's it's great that audit is happening, and it's an opportunity for an auditor to educate the people on site and to ensure compliance, but it's not necessarily the same as, am I building this facility correct? So it's kind of important to make sure that your assurance audits and your inspections are covering the full gamut of hazards, and at the same time not to be lulled into a false sense of security over, audits are happening, everything's great. So I reflect my experience from a couple of years ago. We were doing a lot of site-based inspections, and it was making a difference to site-level compliance in terms of people complying with method statements and what they were supposed to do. In more recent times, we've started to add into that focus on, well, quality aspects. Are we building what we said we're going to do? Do we understand the major hazard here? Do we understand the things that could cause catastrophes? And are we delivering that as well? So, good question. I think any monitoring of audit and assurance should be showing up as a process safety performance indicator, certainly at the high level.
Can I just give you, sorry.
Go for it, Martin, yeah.
It's just to say, in my industry, we find that a lot of companies become a little bit complacent when they do their internal audits. You know, it's always done that way, so it's going to be okay in the future. But getting external auditors in from time to time to put a different perspective on it, to see how other people do the same job, that comes across as quite an advantage.
So design of the audit program is important, and getting other people's views, diverse experiences in to be able to go, and so why do you do it this way, is part of the picture. Going back to training, I think it's quite important to train one's auditors, because the skill is go out there and find something, not go out there and come back with assurance. People see that a little bit negatively, but I'm trying to build, certainly in my organisation, an approach where not only are auditors welcomed, maybe, who knows, we'll see when I retire, not only are auditors welcome, but the process becomes an educational process, a passage on of good stuff, whichever direction. And it may well be that in the context you talk about, Martin, if the external auditor is not necessarily external to the organisation, but certainly external to the local team, then they see good stuff and take it away. And my own experience particularly in engineering and sheet management auditing in the chemical industry, was I went home with as much good stuff as I left behind when I were auditing colleagues around the world.
Yep.
Okay, yeah. In terms of, there was a question on actual examples of identified problems. Certainly, what we have seen in my organisation is we need to move on from just finding something that's not right and saying fix it. So we're going to take our approach to go, okay, something's not right, let us investigate why that is and maybe fix that rather than add the sticking plaster. So this is, fixing the problem at source rather than adding sticking plasters. So maybe some point in the future I can report back on how well that went. There are a couple of, safety critical elements. Yeah, absolutely.
Can I
go for it? Yep.
Sorry, Richard. Can I give some examples on this assurance point of view when it comes to designing products? I think this is quite relevant to everybody in the process industry when it comes to designing any kind of component, really. One main thing to highlight is all the textbooks we have on designing products is based on small deformation calculations. When it comes to large deformations, people have to do simulations sometimes or do some numerical analysis, and people tend to ignore this quite significantly, quite frequently. The other thing is the stress concentration factors, which is again related to this same subject actually. But our industry recently have seen a lot of requests on increasing product speed ratings, how fast things should spin. And this requirement seems like a quite small, quite an easy thing to cope with, but actually it is not when it comes to stress concentration behaving totally different to what your textbooks are actually saying. So understanding this difference is quite critical to actually moving to the next stage of products. And I think since the hydrogen industry is quite growing, processing pollutants in high-speed environments is becoming more crucial these days. I think people should pay even more attention now to those stress concentration factors and review things at least with some simulation.
Great, thank you for that comment. I mean, one of the comments online was about it boils down to knowing what's important and then looking after that one way or another, either through maintenance or checking and so on. And so I couldn't agree more with that comment. However, what's important to you might require some specialist input because, you tell me about stress concentrations. I'm just thinking, well, I need my turbo machinery to work. But it's kind of important that I get that message. Absolutely. Let me just check. Okay, there was a question around, how would somebody doing an assurance audit know if the design was actually suitable for purpose? So, in relation to Bunsfield, it came out in the investigation that the equipment could be, an error could be made during maintenance such that the equipment wouldn't work after maintenance. I think you can't know everything, absolutely, but maybe some idea of checklists, and particularly checklists written by people with some detailed knowledge of a given field can help more generalist auditors to ask the right question. But I think it also comes back to an auditor's skill. You've got to have some general level of understanding plus an interest in finding out more. And those are teachable skills for auditors, I would say, but they are actually very useful skills for all engineers. So we go right to the general. Inquiry is, an inquiring mind and thinking, really, why, how, is a very valuable skill across all of engineering. Okay, I haven't covered a couple of early questions around details on safety integrity levels. What I would recommend, though, is there are still assessment trainings out there, I suspect even within IMechE. So in terms of safety integrity levels, it's worth looking out something more specific in terms of training on that. There was some question about IT resources. I think there are a number of people that will sell IT resources for compliance auditing, but my concern is that without good auditors, then these can just become more of the pieces of paper if one isn't careful. So just watch out for the system overtaking the intent would be my guidance on that. Okay, let me just check one final question. Okay, yeah, regular training. Good point made about actually if maintenance is a routine, shouldn't education or training be a routine? Yeah, that's probably a very valid point. Yeah. So I realise we've come close to the end of the hour. Anybody got any other comments before I move to start to close?
Can I just make one comment? It's just something that's relevant to an industry. For example, if we were testing a level probe in the brewery, we'd probably fill a tank up with water and make sure it works. Whereas when you've got 1 million litres of fuel, you can't really do that. So you've got to find some way of testing that level probe and make sure it works 100%, possibly by just standing by the tank while it fills to capacity and make sure it works, and do that several times.
Yeah, I mean, I've seen that done in the chemical industry, monitor manually and visually, but you make a good point that designers of equipment should be designing for how do we proof test as well, especially if that equipment is going to be safety critical. So, yeah, very valid point. Crikey, more questions coming in. What am I going to do? Okay, so there's a question about should a safety case be separated into small sections and be reviewed through the year? Very good idea, actually. Then we can talk turkey about sort of specific aspects of our safety case and maybe even get expertise in outside. So rather than trying to eat the whole elephant in one go, if we break it down into small areas and rotate those through a sort of routine across a period of time. That's a really good way of thinking about auditing. So now you might say, well, I've only tested this part once every 2 years, but at least I've tested every part over 2 years, and I did them in detail. So balancing up how deep you go with how wide you go is worth thinking about in terms of when you're developing audit programs. So it's a good question. Okay, what I'm going to do is I'm just going to move the slides on. You should be able to see in your auditorium an overview tab where these other resources are available to you, so you can click on any of these. That list is for Bunsfield, and then there's some more that I tend to share on most of these events around leadership in process safety management, and indeed some of the information, particularly the OECD information, is a result of the incidents that occurred in 2005, including Buncefield. So things like the Process Safety Leadership Group and so on. And indeed the PSM Competence Programme. I chair the board that looks after that programme. If you have a need for general upskilling in process safety management, they're certainly worth a look. Thinking about future events, I said this is one of a series. The next event is going to be on the 16th of May, and we're going to talk about investigation, not necessarily the act of investigation, but more about how do we get to the underlying reasons why incidents occur. Do we, in fact, get to underlying reasons, and if so, what do we do with that information? So some of the questions today were around properly learning from experience and whether we get that right back to designers, but that perhaps will come up at the next time. So the other feature I want to talk about on the next occasion is are we investigating the right things, and use of imagination when we think about potential for any given loss event. How bad could it have been, and therefore should we apply more thinking power to this event? So that's the next event. And finally for today, hopefully these will have popped up for you, but there is a link for anybody who needs a CPD certificate to Murat's IMechE email. But the link you can see for feedback that's currently on the screen is, I'm afraid, incorrect. The one that came up in your pop-up should be correct. So please do feedback. Let us know how you think this went, and we will try to base future events on some of the things we hear. But I will just check if my fellow panelists have any final comments. Martin, any last comments?
No, I think we covered a lot today. There's a lot more to cover.
Always.
Always. So I think we went through what we could do in the time.
Okay, great. Thank you. Murat, any final thoughts?
No, thank you very much, Richard. It was
okay, great.
Good. Thank you.
Pamela?
None from me. Thank you for sharing this, Richard. And
finally, Stephen.
No, nothing from me. Thanks, Richard.
So I just want to thank my fellow panelists, and I hope you found this interesting. It has been recorded and will be available for anybody that wants to review anything that was said, but also feel free to pass links on to your colleagues if there's anybody that you know that couldn't make it and would be interested. So thank you all, and see you next time.
Thank you.
Thank you.